Let's take a look at question number 30. And it looks like we're starting to get into some other properties. So properties of exponents, when we have like terms, x squared plus x squared, what we do is we add, to simplify, they're like terms, so we add the coefficients. So 3 plus 4 is 7. We'll put that one in as 7. X squared. Now this one, we are multiplying things with exponents. So when we do this, we take the numbers times each other. So 6 times 8. And then when we've got the x's, what we're doing is we're adding the exponents together. When you multiply x squared times x to the third, you're adding the exponents together. So we get 48 x to the fifth. Okay. An exponent to an exponent. So exponent to that's when we multiply them. However, when you've got this on the outside, you're really multiplying here, you're raising everything to the second power. So it's got to distribute. So 5 squared times x to the 3 times 2. So that's going to give you 5 squared is 25, x to the 6. Okay. The other way to think of this is it's 5x to the third times 5x to the third. Right, so we do it this way. We take 5 times 5, we get 25, and 3 plus 3 is 6. So we've broken it down to multiplication, used a different property, but we come up with the same answer. Okay. For this next one, we could just look at it. We're taking 8 over x times 8 over x. That's going to give us 8 times 8 is 64 x squared. Or you could look at it as distributing the exponent to the top and the bottom. And finally, we're going to subtract exponents when we divide. So 45 divided by 9, 9 goes into 45, so 5 times. So those cancel, 9's cancel out. And then 8 minus 2, we're going to be left with x to the 6. 8 minus 2, so 5x to the 6. 5x to the 6. And those all correct. 32. Okay, so this is using exponents with radicals. So radical with an index. So remember, this radical 3, this index 3 radical, cube root, that is telling us that this whole thing is raised to the 1/3 power. Remember that a radical, whatever the index is, that's something to the 1 over n power. Whatever's in here. Could be an x or whatever. So, but the symbol gives us that. And then we can simplify, because when we multiply the exponents, we get 2 times 1/3. That's going to be m to the 2/3. So that's a simple way of writing with the fractional exponents. Now, when there is no exponent or index, so just the square root by itself, what they've done is it's actually a 2. square roots have a 2 power there, so that would be something to the 1/2 power. Okay, so for this one, we're going to get y to the 8th raised to the 1/2 power, and again, you multiply 8 times 1/2. 8 divided by 2 is going to be 4, so we get y to the 4th power. I'll come back and put those in. And if we're going to enter it in directly, when we raise the exponent, to get proper order of operation, we have to put a parentheses, 2 divided by 3, okay, for that to come out correctly. If we don't put those parentheses, it raises it to the 2nd power and it divides the whole thing by 3. You'll see it just doesn't do it right. This one is y to the 4th, so we don't need that parentheses because we don't have a fractional exponent, because it reduced. Simplifying square roots, a little bit more work in here. What we're looking for is this number 252. We're looking for a perfect square inside there. So we're kind of factoring out 252. So what are the perfect squares, right? Well, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49. And so what we're trying to see is what number actually divides into 252. And part of this is a little bit of guess and check. Eight is 64, but it's got to be one of these if we're going to be able to reduce it. So what I'm going to do, I'll pull up my calculator. Let's take 252, and let's see if one of these divides evenly into us. Divided by 64. That works. No, we got a decimal, and that would be close to 4 times 64. Let's try 6. So 6 squared is 36. Let's try 252. Did it backwards. 252 divided by 36. That worked. It's 7. So 52 can be rewritten as the square root of 36 times 7. And so then that's the square root of 36 times the square root of 7. Square root of 36 is 6, so that's 6. Square root of 7. That's what we put in here for reducing square roots. 6, we're going to need this, right? Square root of 7. That's the way they're going to want it. Now, 245 is actually a little bit easier in a sense, because what divides into something that ends in a 5? Well, it has to have a 5 as well. So 25 is a pretty good bet that 25 goes into 245. 245 divided by 25. Again, it's got to be the perfect square. No, it didn't work. Well, 10 is 100 squared. How about 9? Well, and 9.8, so 245, maybe 3. See, 5, that's 6, plus 5 is 11. 3 doesn't go into that, so 9's not going to go into that. So if you were just kind of guessing, maybe we were off. Let's see, can I divide that by maybe 49? Let's see, does 49 go into that evenly? It does. Kind of a, wasn't. So 5 goes into it 49 times. So I should have stuck with my 5s. 25 didn't work, just go with the 5. So what I do is square root of 245 is the same thing as the square root of 49 times 5, because 245 is 49 times 5. This is the square root of 49 times the square root of 5. Square root of 49 is 7. Square root of 5 is left because it doesn't reduce any further. So then we come in here. We'll put in 7, square root of 5. And there we are. And we've got it. Okay, so that's simplifying square roots. Question 34. Simplify each of the following, write in the form a plus bi. Okay, so this is our complex numbers. When we have a square root of a negative number, remember that that's where the imaginary numbers come in. So we're going to go with 6. Square root of 16 is 4. 4. And because there's a negative, that gives us an I. Okay, the imaginary number divided by 2. And so then we distribute the 2 to both of these, right? This is 6 divided by 2 plus 4 plus 4i over 2. So reducing 6 divided by 2 is 3. 4 divided by 2 is 2. And it's simplified down. Same thing over here, but we probably won't get as much as far as reducing, but what's the square root of 9? So we've got 7 minus the square root of 9, that's going to be 3, right? Square root of 9 is 3, but since it was negative, we get the I over 4. That's not going to reduce, so let's just leave it as it is. So we get a fraction, and we'll put 7 minus 3i in the top, and we'll put 4 in the denominator. Enter that in. Error, invalid form. Oh, a plus bi. Okay. Now, good try, but they want them as separate. Oh, and it wasn't plus and it was minus. So let's do this. Let's start over. We'll do one fraction as 7 over 3. That's our 7 over 4. And we'll subtract the other function, which will be 3i over 4. So now it says, yeah, we'll take it. And it works. Okay. 35. Getting down here. Simplify completely. Use only positive exponents in your answers. So we're looking for adding like terms or, well, actually, we're going to divide everything, right? So it's a distributive property. This 3x will divide into each of these terms. So we get 18x to the 5th over 3x. And remember, that's an x to the 1, so when we subtract exponents, we'll get an x to the 4th on this one. 6x to the 3rd divided by 3x to the 1 plus 3x divided by 3x. Okay, 18 divided by 3 is 6, x to the 5th and x to the 1, so this sort of cancels out, leaving a 4. So x to the 4th, we're reducing down. 6 divided by 3 is 2, and then x to the 3 minus 1 is going to give us x squared. And finally, x to the 3 over x to the 3 is going to reduce down to 1. Anything divided by itself is always equal to 1. So there's our answer there. squared plus 1. Syntax okay. So we can get 36. Lots of review here. Operations with polynomials, so we're adding, we're multiplying, and we're squaring. When we add, we just add like terms, so 3x plus 5x, that's going to give us 8x, and then we combine the like terms here, negative 4 plus 8. So we have 8x plus 4, 8 minus 4. Now this second one, when we have subtraction, the thing we want to be careful about is that negative has to distribute to both of them. So what we end up with is 3x minus 4 minus 5x minus 8. So we get a little bit different than the last one. 3x minus 5x, that's going to give us a negative 2x. And then a negative 4 and negative 8, there's the same, so we add them together, same signs, it's going to give us negative 12. So down here, we're going to be asked to FOIL. So we multiply the first, 3x times 5x, that's going to give us 15x squared. And we take 3x to multiply the last, 3x times 8, that'll be plus 24x. We take the inners, minus 4 times 5x, that'll give us a negative 20x. And then the last, negative 4 times 8, will be negative 32. Okay. So 15x, we can combine these. 24 minus 20 is positive 4x minus 32. Just type that in. 15x, not x, it's x squared, not x to the x, plus 4x minus 32. Okay. And this last one, a similar thing. Now, do not distribute this exponent through. Some people will try that, but what it means is it's two copies of 3x minus 4. So it's 3x minus 4 times 3x minus 4. And again, we get the distributive property. 3x times 3x is going to give us a 9x squared. 3x times negative 4 will give us a negative 12x. Negative 4 times 3x gives us another negative 12x. And then negative 4 times negative 4 gives us a plus 16. Combine the middle term. Now, they do not cancel. They're both negative. They add together. We get negative 24x. So 9x squared minus 24x plus 16. And those are all correct. 37, a few more. We'll take a little break. Write the following quadratic expression in completely factored form. So what we have to see is it is a difference of squares. And when we have a difference of squares, a squared minus b squared, two things squared, it factors into a plus b times a minus b. So when we look at this x squared minus 36, what that really is it's x squared minus 6 squared, because 6 squared is 36. So it's going to be x plus 6, x minus 6. That's our factored form. B6. Okay. Now, I'm just let's see if they're always going to be a difference of squares. I think this one will be. yeah, it's always going to be a difference of squares. So that's really one of the items they want us to do. Difference of squares. So know that one. 38. Operations on polynomial original expression. Now we want to expand. Now one of the things is we cannot just start distributing the 2 because we've got an order of operations. We've got this exponent here. We have to deal with it first. So this is 2. What we have to do is it's x minus 5 times x minus 5. That's what being raised to the second power means, is it multiplies by itself, then plus 6. Now that the exponent is gone, the squared has been, we've addressed that. If you wanted to, you could distribute the 2, or you could FOIL out. You could do it almost, really in whichever order. I like to go ahead and take care of this. As 2 distributes to just the first part, we get 2x minus 10, and then we get x minus 5. Now we FOIL. So 2x times x, that's going to give us 2x squared. 2x times negative 5, it's negative 10x. Negative 10x. Again, and then a negative 10 times negative 5 will give us a plus 50. And so we've taken care of that. We've now got the plus 6. And then it's just a matter of combining like terms. Again, be careful here in the middle. This does not cancel. Negative and negative are, we add them together because they're both going in the negative direction. So it's going to be a negative 20. So to finish this up, we've got 2x squared minus 20x plus 56, adding the 50 and the 6 together. And we're all good. So watch that order of operations, following through with that. 2 more, take a little break. So now factoring a quadratic. On these, one of the things we look for factoring is are there common factors? And notice each of these has a 2. So we can factor out a 2. 26 divided by 2, right? To take the 2 out is going to be 13. And 84 divided by 2, so factoring out the 2 will be 42. And now let's check to see if we can factor this trinomial. Let me show you something that will help with the factoring. We can actually use decimals. We're going to graph this x squared plus 3x plus 42. Okay, so there's a decimals. We're going to clear all of this out. And we're going to graph this as y equals x squared plus 13x plus 42. And now we need to zoom in quite a bit. So I'll bring it. It's just over. We want to stay sort of here. Let's kind of keep zooming in. A lot. We're way zoomed out. And what we see is where it crosses the x-axis, -7 and -6. The reverse of those, +7 and +6, are what our factors are going to be. And the reason is because this is where x equals 0. So what we do with this is this is telling us that one of the zeros is x equals -7. The other one is x equals -6. what we want to do is, since these are what are called zeros, or where the y equals 0 in this case, crossing the x-axis, we solve these for 0. So I add 7 to both sides. I want to get 0 on one side. X plus 7 equals 0. Over here I add 6 to both sides, giving me x plus 6 equals 0. The thing about this, these are the two factors we need when you multiply these together. So we still have this 2, it just comes along, and this inside part will now factor into x plus 7 times x plus 6. And notice 7 times 6 is 42. 7 plus 6, right? We get 7x plus 6x. 7 plus 6 is 13. It works. Okay. So if you're not real comfortable with factoring, take it, graph it, and where it crosses the x-axis gives you, sort of gives you what your factors are going to be. Notice it gives you the reverse signs because you have to come and solve it. The factored form will be with moving the number to the same size as the x so that it's equal to 0. Okay, so that's our answer there. Let's go ahead and put that in. Fully factored form. Don't forget that too, because it's still out there. What we're going to have is an x plus 7. And the order of this is not really important. It could have been, we could have put the x plus 6 first. Watch, it's going to be correct. Just like that. But you have to get the common thing factored out first. Otherwise, you would just see that part. All right, where are we? 39. One more and we'll take a break. So factor out the greatest common factor out of each. So this one, not only is there a common number that can come out, but notice there's an x. So there's, and what it always is it's the least amount. So this last one can give 3 x's. So we know that an x to the third can come out of each of these. We know a 2 could come out, but probably a little bit more, maybe. This is 2 times 6. Well, 4 can go into that. Does 4 go into 28? Yeah, 4 goes into each of these, so we can take out a 4. To figure out what's left behind, what we can do is just take this 12x over 6, and what we're going to do is we're going to divide out 4x to the third. And we've got our 28x to the fourth, and we're going to divide out 4x to the third. And then we've got 20x to the third. We're going to divide out 4x to the third. And that'll help us see what was left inside, because that's what we're taking out. So in this, 4 goes into 12 3 times, and subtracting exponents, what we have is we have 3 left in the top here. 6 minus 3 is 3. 28 divided by 4, so 4 goes into both of these. 28 divided by 4 is 7. And then when I subtract 4 minus 3, all I have is 1 left. So this cancels, and I'm left with x to the 1 power. 20 divided by 4, so 4 goes into 4 once. 4 goes into 25 times. And then x to the third cancels with x to the third. That's just 1. So our final answer is going to be 4x to the third, 3x to the third, plus 7x to the first power, plus 5. We factored out the greatest common factor, GCF, 4x to the third, 3x to the third, plus 7x plus 5. Okay. Submit it. It's all good. And we'll take a little break there.